Welcome to aminacademy.com. In electrical engineering, let us discuss about resistors in series connections. Resistors are said to be connected in series when they are daisy chained together in a single line. Since all the current flowing through the first resistor has no other way to go, it must also pass through the second resistor and the third resistor and so on. Then resistors in series have a common current. Here, any number of resistors connected in series, they have common current flow through it. Then we can see that current IR1, resistance 1 equal to current through IR2, like equal IR3, like suppose it is 1 milliamps. Each resistor have current 1 milliamps. In the following example, the resistors R1, R2, R3 are all connected together in series between the point A and B. Here, the point A and B connected 1 ohm resistor, 2 ohm resistor, 3 ohm resistor. Here, the current is everywhere is 1 milliamps, but the voltage is changed. That is V equal to IR. IR means 1 kilo ohm into 1 milliamps is 1 volt. 2 kilo ohm into 1 milliamp is 2 ohm, and here 6 volts. Here 1 volt, 2 volts, 6 volts. So the resistors have same current flow through it, but voltages are different. That means here that resistor is more, the voltage also more. The total voltage is equal to 9 volts. That is 1 plus 2 plus 6, 9 volt. Look at here. Resistance R1 equal to IR1, 1 milliamps into 1 kilo volt is 1 volt. That means voltage across R1, R2, R3 is we calculated like. As the resistors are connected together in the series, the same current passes through each resistor in the chain, and the total resistance RT of the circuit must be equal to the sum of all the individual resistors added together. Therefore, resistance equivalent is R1 plus R2 plus R3, 1 kilo ohm plus 2 kilo ohm, 3 kilo ohm, totally 9 kilo ohms. Here, this is the picture. The voltage across the point A and B is 9 volts, passes through 1 milliamps and through 9 kilo ohm. The total resistance is generally known as equivalent resistance and can be defined as a single value of the resistance that can replace any number of resistors in series without altering the values of the current or the voltage in the circuit. That means equivalent resistance is the sum of all resistors connected in series, and there is no changes in current pass through it. That means if same current pass through it through the single resistance together connected together, all the resistance is considered as a equivalent resistance. So R total is R1 plus R2 plus R3, which is up to Rn, etc. Here, look at this. Here R1, R and R, two equal resistance is connected in series. That equivalent resistance is 2R. Here R1 plus R2, total resistance is R1 plus R2. That is, two individual resistance different ohms is together R1 plus R2. Series resistor voltage. The voltage across each resistor connected in series follows different rules so that the series current. We know from the above circuit the total supply voltage across the resistors is equal to the sum of potential difference across R1, R2, R3. We know that potential difference, that is, each potential is addition of all potential in individual resistors, totally 9 volts here. This is total resistance 1 plus 2 plus 6, 9 volts total voltage. Now V total, that means total voltage across the 3 resistors up to n resistor is VR1, VR2, VR3, like voltage through R1, voltage through R2, like up to voltage through any number of resistors in series. Now, one example, listen here. Using Ohm's law, the circuit is equivalent series resistance. We have to find the equivalent series resistance. The series current voltage drop and power for each resistor in the following resistor in series circuit. Here this R1 total resistors are equivalent. R equivalent is R1 plus R2 plus R3. Which is equal 10 plus 20 plus 30 equal 60 ohm. Total resistance is 60 ohm. The voltage across is 12. So we know the formula V equal to IR, Ohm's law. From this, each current we have to calculate current through all resistance is equal. Then I equal to VR. In general, you can write I1 equal to V R1. V is 12 volts common volt and R1 is 10 is 1.2 amps. 1.2 amps. Like everywhere current is 1.2 amps. I1 current is same everywhere, not here. Because total individual current you can find everywhere current is same. Therefore, I equal V total is 12 60. Here 1 over 5 is equal to 0.2 amps. Each current through each resistor is 1.2 amps. Now we can find each voltage drop. V1, look, V1 equal to IR1. Common voltage, common resistance, common amps is 2. R1 10 is 2 volts. Like V2 IR2 0.2 into 24 volts. Like V3 equal 0.2 into 30 equal to 6 volts. Therefore, total volts V equal V1 plus V2 plus V3, which is equal 246. 2 plus 4 plus 6 equal to 12 volts. That is 12 volt is split here like this manner, 246. Now we have to find voltage drop and power of each circuit. Here power P1 power in through first resistance V1 I1. V1 is 2 into 0.2 amps is 0.2. 0.2 equal 0.4 watts. Like P2 4.2 equal 0.8 volt. P3 6 into 0.2 is 1.2 watts. 1.2 watts. So P1 is the power through first resistor is 0.4 watts, second is 0.8 watts, third is 1.2 watts. This all together is Here resistor 0.2 resistors can be represented as 200 milliamps. Also like you can write it. Here in series resistors option series circuit is useful to get a circuit divider, voltage circuit divider. We can see this above example. Although the supply voltage is 12 volts, different voltages or different drops appear across each resistors within the series network. Connecting resistors in series like this across a single DC supply has one major advantage. Different voltages appear across each resistors, producing a very handy circuit called voltage divider network. That means through the each resistor voltage is some different voltage we are getting. It's useful for finding to get the voltage divider. Here look at this voltage divider. Look this voltage in, voltage out. Here this through resistors 1 R1 voltage in is I R1 plus R2. Suppose here voltage 1 is R1, voltage 1 is total voltage into R1 over total resistance is R1 plus R2. Like this here voltage out in through the second resistors is voltage out is generally is voltage in and R2 over R1 plus R. Here first voltage V1 is R1 over R1 plus R2. Now suppose this is V2. Second voltage is Vin. Vin is here R2 comes. Here V2. V2 into R2 by R1. Like this rule we can find division voltages in voltage divider. The circuit shown resistor is just two resistors R1 or R2 connected together in series across the supply voltage Vin. One side of the power supply voltage is connected to resistors R1 and the voltage output is V out is taken from across the resistors R2. Like this. The value of this output voltage is given by the corresponding formulas. That is here V out equal to V in into R1 by plus R2. Like here V1 2 means here R2 comes. Here V1 means here R1 comes. Look at this here. 4 resistors are connected in series. 10 ohm, 20 ohm, 30 ohm, 40 ohm. Like the total resistance we know, the adding of all. Suppose we want to resistor through voltage drop through AB is 30 over this total. That is R3 over R1 plus R2 by plus R3 plus R4. That is 30 over 10 plus 20 plus 30 plus 40. That is equal 3 volts. Here because this is 100, down is 100, up is 30, 30 over 100 is 0.3 into 10 volt is 0.3 into 10 is 3 volts. Like this voltage drop across any resistor we can find by using this formula. We can also apply the same idea to group the resistors in the series chain. Connecting two equal values of resistors, say of 50 volts each, that together as a potential divider network across 12 volts will do this very nicely until we connect the total. That means here the 50 volt is dropped 50 ohms through this one means we can find by Ohm's law, we can find the current, power, everything. Look at this one example here. Resistors in series example. Calculate the voltage drop across X and Y. Here R1 is 50 ohm, R2 is 50 ohm, the total is, we know that is 100 ohm. Now without RL, suppose the load, external load RL is not connected. RL is connected means here voltage drop across X and Y, the point X and Y here 50 Rxy is 50 volts, V out equal to V in into R1 R2 plus over R1 plus R2, that is 12 volts. Input voltage is 12 volts. The R2 is 50 divided by 50 plus 50 is 100. 50 by 100 is 6 volts. Like this here, with RL is connected. This is Rxy. Here without RL, here this RL is not considered. Here RL is considered means Rxy is 50 volts because it is in parallel. The two resistors R1 plus R2 is these are in parallel, so 50 plus 50. So we have equivalent resistance of 50 plus 50 in parallel is 25 volts. Regarding that, V out is V in R2 by R1 plus R2 is, here V in is 12 volt, here 25 because it's two resistors, that is load resistance 50 is connected with this R2. So we have 25 over 20 plus 25, which is equal to 4 volts. That means here without RL connected, load resistance not connected, we can get output as 6 volt. Here load resistance RL is connected, then we can get 4 volts on. That is, we can split the voltages like. The effect of reducing a signal or voltage level is known as attenuation. The voltage divider circuit is the simplest way of producing a lower voltage from a higher voltage and is the basic operating mechanism of the potentiometer. Potentiometer is worked based on the voltage divider circuit. Here, application of resistors in series. Resistors in series can be used to produce a different voltages across themselves, and this type of resistors network is very useful for producing a voltage divider network. If we replace one of the resistors in the voltage divider circuit above with a sensor such as a thermistor, light dependent resistors LDR, or even a switch, we can convert an analog quantity being sensed into suitable electrical signal which is capable of being measured. This is a thermistor circuit. In general, two or more resistors are said to be connected in series when the same amount of current flows through all the resistors. In such a circuit, the voltage across each resistor is different. In a series connection, if any resistor is broken or a fault across, then the entire circuit is turned off because these resistors are in series. One resistor is out of work, then other complete circuit is not working. So far we have done detailedly about resistors in series circuit and its uses and the potential divider like this before. We have done. Please subscribe our YouTube channel.